JAGA Systems is based on volumetric detection instead of perimetric detection. Many security systems are based on sensors, infrared walls, or microwave barriers that will only protect the fence area, for example. Our system will secure the whole area, not just the perimeter. We are able to track the intruder the entire time.
As you can see here, the single light photon is emitted from the sensor, hits an object like a tree, and bounces back to the LiDAR sensor, at which point the data from the light photon's travels is recorded. It is measuring distance and time. The amazing thing about this is that it works for non-stationary objects in real time, such as pedestrians, bicyclists, and other cars. Because LiDAR is its own light source, it can even see at night. This is an advantage over cameras, which have trouble in darkness. A good LiDAR has from 8 to 128 laser beams to measure the environment. The laser beams in the LiDAR emit billions of light photons per second at 360 degrees in order to completely see the surrounding world. It is pretty amazing that billions of data points and calculations are happening in real time. This allows the car to see and keep drivers, occupants, and all other road users safe. It is kind of like spraying paint all over the surrounding environment in order to highlight objects, make them recognizable, and show movement. Conversely, here you have a two-dimensional picture of the street via camera sensor. Cameras are basically a flat representation of the environment. Where a 2D vision system falls short, LiDAR is able to show a real-time 3D view of its surrounding environment. After all, our world is three-dimensional, not flat. Other issues that affect cameras' ability to see include optical illusions and lack of measurement. Also, cameras require more computer power and run hotter than a LiDAR sensor. None of these affect LiDAR. With rotating LiDAR, vehicles have a 360-degree, three-dimensional view of the world in real time that goes far beyond the scope of the camera and even beyond the human eye. Here is another example of how the LiDAR sensor can see in comparison to a suite of sensors, including camera and radar. The car on the left, equipped with a suite of sensors, still has blind spots. With the LiDAR on the right, issues such as blind spots or wide-angle hazards are non-existent. It can see 360 degrees at a range of up to 300 meters.
One of the main advantages of JAGA Systems is the 3D map, which was created using Unity 3D engine. We believe that the world is in 3D and our system should be too. Our map's environment is in the real scale and all components in the map are in the exact position from the real environment. The rest of the security developers are using 2D, just a photo, not 3D, making our system very unique. How do we make the 3D environment? It's actually quite easy. It can be done by yourself using photogrammetry, or we can do it for you. In Google Maps, all you have to do is set a border around the area on which you would like to have in the 3D map. You will then set a flying mission for the drone, which will then take real pictures of the area that you had preset. Once the drone has completed the pictures for the area, you will then load the pictures into the application, creating your 3D map. unique system, you are able to place the camera and LiDAR in the best possible position before placing them in the real environment. The user-friendly drag and drop is an easy way to place the camera in the correct position. The blue light will indicate which way the camera is pointing. The best part of this is that you can also calibrate cameras in the real environment to your 3D environment. During calibration, you will see the 3D map on the right side and the real environment on the left side. Another unique feature of JAGA Systems is that you will always be able to see the area where the camera will not be able to cover. The system will create a shadow for areas that are not covered by the camera. The green light shows the area the camera can cover. This will help in camera placement before the actual placement in the real environment or installation. Using the drag and drop system, you will be able to locate the best possible position for the camera so it is able to cover more of an area. Along with the camera, it is possible to do the same thing with the LiDAR detector. Using the drag and drop with the LiDAR makes it possible to place the LiDAR in the best possible position. You are also able to rotate the detector. When placing the LiDAR detector, you will see the white points, static points, which will show which area the LiDAR is detecting. Once you have the LiDAR placed, you are able to test the system using a virtual reality pawn. The pawn can show you the exact amount of points that the LiDAR will hit on a real person. These green dots on the intruder show that it is not possible to go undetected. The virtual pawn allows you to make sure that the whole area is secure and there are not any loopholes or areas that are not secure. The setting of alarm zones is one of the most unique parts of our system. As the LiDAR detector can detect anywhere, you are able to set up zones. There can be many different zones in the secured area. You can adjust the height, length, size, and color of the zones. The zones allow changes in what can be secure and what isn't secure. For example, if you would like an area secure at night, but not during the day, you are able to set up a zone that will fulfill these requirements. Another example is if you would like to go for a swim, you are able to place a zone around the pool so the area is alarm-free, but the other areas are still active. With the use of zones and LiDARs, you are able to protect the entire area compared to only protecting the perimeter. Alarm event, you can see the intruder in the bounding box. The most amazing part of this is the use of the LiDAR and the cameras together. All components work together in the system. It is operator-free. If you notice down at the bottom of the screen, there are 3 camera views. While the intruder is moving around, the first screen shows where the intruder is. Once the intruder is almost out of sight of the first screen camera, the second screen camera will switch to the first screen camera and prepare itself to catch sight of the intruder once the other camera loses sight of the intruder. This is very, very unique. Because of this, you will never have to worry about where the intruder is.